have homework 1.1, which a few people have done, but other people
Miss
still need to
Walker?
create a homework account. So I
Hello?
changed the due date to next Monday, which should be the 4th. Oh, and here, I got the sound on. So if I couldn't hear you, I got it now. Yeah, and I have the chat on the side and the volume on or set.
Okay, so can you hear me?
Yeah.
Okay, so what I was gonna ask is I did the homework and it automatically registered the grade for it, but one of the questions was not a multiple choice question. It was a question I had to write, and it didn't, like, the answer didn't register like as a point. So right now I'm sitting at 9 out of 10 because it still needs to be graded.
I got to grade it.
Yeah.
I'll try to grade it today.
Okay.
As soon as I give it a check mark, your score will go up.
All right, gotcha.
Yeah. Thanks for asking. I'll have to write it down. It's the 7th. And as you do your homework, my lab will record your score. And I've linked my lab to Canvas to send the score over to that gradebook. Sometimes I need to go and refresh your scores so that it's all updated. But aside from those problems that I need to grade, your score will go up as you do your problems. Okay, there's no homework for 1.2. And just to note that this homework is 10 questions, and give the questions a try. You have unlimited attempts and they're really not like scary math questions. Right now we're just learning vocabulary. So it's asking about definitions. This shouldn't be that difficult, but if it is, you can visit my office hour and then we can, get your homework score on track and not let assignments pile up. Okay, I will probably send an email to those of you who haven't created a homework account sometime this week, so that way we can maybe meet together and figure it out together. Other than that, we're just doing more notes. We're still working on notes for 1.2. I'm going to back up a little bit and go over the simple random sampling with replacement and there's simple random sampling without replacement. And then we'll do that example that we started. Again, the first few sections, maybe the first couple chapters, is a lot of vocabulary. So we've got to go over definitions, but once we know those definitions and we get to meet in class, I can give you activities and worksheets that you can get practice from. So, simple random sampling has 2 options, with replacement or without. usually don't do this type of sampling, but if we do, it's where you select someone from your population and then maybe record the information you need, and you put that person back, or you put that item back into the population. Then you can select them again if you want to. This is where a member of the population can be selected more than once. Okay, and then the other one is without replacement. So once you select someone, you can't put them back. You have to choose someone else to be in the sample if you want some more people in your sample. Okay. So I'll usually probably just write all of this down, but if there's an acronym in your homework, SRS, it's the simple random sampling without replacement. Okay, a member of the population can be selected only once. Okay, then we did an example on the side. This example is something you won't see on your homework. It won't be on the test. It's just for me to give you an idea of what things look like mathematically. So we're going to have a population of 5 people. Where the people are Angel, Bob, Casey, Dana, and Evan. Okay, these people are members of a study. Represent the population. So the population is all of the members in your study. These are all the people I'm looking at. All right, then we just used a variable for each name, or just like simplify this. A for Angel, B for Bob. I guess it's not a variable, it's just a abbreviation. So A for Angel. Keep going down. C for Casey, D for Dana, E for Evan. For the first part, we're going to list all possible samples of size 2 without replacement. So the population is the set of all of the people in your study. So we're going to use set notation for population is equal to set, which is going to start with a curly bracket, like a little curve, hook, curve. Okay. And then you list the elements or members of your set. Separate them with a comma. A, comma, B, comma, C, comma, D. Okay. You don't want to write A again because you've already got that represented in a set. Each person we've got listed, and then close the set with a curly bracket. Okay. Getting every possible sample of size 2. To stay organized, I usually pick this first person and then go to the next and stay with that first person and then skip and over to C. So first set is AB, next we'll do AC, AD, AE. Start your subset with the bracket. And we're going to start with A and B. Separate them with a comma, close your set with another bracket, and then we'll go down here and put the next set. Starts with the bracket. We're going to use AC, separate them with a comma, and then close the set. Okay, then we're at AD. Which it's the same as DA, AD and DA. same set. I'm just trying to stay organized with not getting those repeats. And we're going to go A, E. Okay, I'm going to stop using A and move over to B. And we're going to keep going this way. B, C. B, D, and B, E. C, D, B, E. Okay, I've taken care of B. So I'm going to go to C and have C, D as another sample of size 2. Did this one, CE. I'll just put it over here. Okay, and then the last, CD, CE. Last one would be DE. Start the set, put in your elements for your members, and close the set. 6, 7, 8, 9, 10. 10 possible subsets of your population of size 2, or 10 possible samples of size 2. And then if we did simple random sampling, I would pick one of these sets at random. So maybe close my eyes and then just like kind of see what happens. And I pick this set, just randomly chosen that. And that's like an example of simple random sampling, where every subset of the same size is equally likely to be selected. Okay, one more idea here. We cannot have something like AA because we were sampling without replacement. Looks like because members are selected without replacement. have a new example. I'm going to have a population of size 4, and I'm going to just represent members of the population with letters right away. So this time it's a population that includes W, X, Y, and Z. Okay. Let P be a population. I'm just going to put the word population. Okay. Population. Be equal to set that contains W, X, Y, and Z. For the first part, we're gonna list, just do one part. We're gonna get all samples of size 2. Without replacement. The samples are going to be subsets of that set. And each one has 2 elements in it. We don't want to repeat any of the sets. So I'm just going to put a side note. If you have WX, it's the same as XW. So similar to before, I'm going to stay organized by starting with W and get every pair from W along with these. Then I'll move to X and then Y, and then we'll probably be done. Okay. First subset is WX. And you start the set, put in the elements, separate with a comma, and then close the set. WX, WY. I put an extra comma out here just to separate this set from that set, but I can also just list them all down. WZ. And we're done using W, and we're going to move over to X. XY, is one set, and then we'll have X, Z as another. And we've used X, we're moving over to Y. YZ is the last possible sample of size 2. Okay, so far I've only described simple random sampling as a method of sampling. That's where you just randomly select one of your samples of a certain size, and every sample of that size is equally likely to be chosen. So like before, I could like close my eyes, kind of like move around a little and just pick something. Say I picked this one, and then that was randomly selected, and it was just as likely to be chosen as all of the other sets. Or I could give each set a name or number, like number 1, 2, 3, 4, 5, 6. Use a random number generator, and whatever number that gives me, pick that set. So other forms of sampling are described in our next section. So we did simple random sampling, but now we're going to talk about like 4 or 5 other kinds of sampling, or types of sampling. So we're starting 1.3 notes, but I haven't made any homework for 1.3. I'll probably make some today or tomorrow. And mostly what it does is tell you how they selected a sample, and you pick what kind of sampling that was. So they'll explain how they got their data, and you match that with one of these definitions. I'm going to write down the one we've already gone over. Sorry. Simple random sampling. every sample of that side had an equal chance of being selected. Sample was chosen. We're going to draw sort of a little example. We're going to have, let's put 7 people in our population. Okay, I'm not gonna like write this as a set. We're just gonna draw 7 people and I'm gonna number each person. Okay, then let's say we use like a random number generator, which you can find on Google. Just pops right up when you type in random number generator. To get some sample, let's get a sample of size 3. Then we, click generate 1, 2, 3 times, and let's say it's spits out the numbers 2, 5, and 7. picking this person. Just randomly chosen 3 people out of all 7 people. You could have chosen any of those people, so this is simple random sampling. Okay, I'm gonna write it with set notation where we've got 2, 5, 7, then close the set. The next one is called systematic random sampling. Systematic sample is obtained by ordering the population and then choosing every kth individual. So maybe like every 6th person you would pick. I'm going to write down the steps and then maybe we'll get to an example. But just to share a quick example, I remember something like the population being all people who visit the mall on the weekend. And then someone stands at the entrance of the mall and they select every 10th person that walks in and asks them the question from the survey. So that's one way to sample is you pick a number and then after so many people, select one person. Then choose the same amount of people over and select. Same amount over, select. These are the steps. First, you need to find the population size, if you can. Use capital N to represent the population size. So capital N is the number of people in the population. Next, choose your sample size. We're going to call that number lowercase n. This population size is big N, sample size is little n. Next, find or compute the value capital N divided by lowercase n, and then round down. So it's going to be some counting number you can count on your fingers. You're going to round down to that number, and that value is called k, lowercase k. K. Then you have to pick a number between 1 and k as a starting place. And then we're going to wrap it up in just a second. Okay. So you've got your starting place, and you want to pick that person to start with, and then you want to go over k people and pick that person. K people, pick that person, and keep doing that until you're done. Kth individual. When we come back, we'll do an example where I have an actual population size and I have actual numbers for all of these. We pick some number k, It's going to end up being 5. We're going to choose every 5th person. Also, back when I first took stats, my teacher told me that when you put your iPod on shuffle, if you have an iPod, this is how it picks your songs. It will pick a song at random, and it'll go over like 12 songs and choose that one, another 12 songs and choose that one. And, you know, keeps playing songs when you put it on shuffle. So we'll do more notes on Wednesday.